Article 517.30c Exception 3 of the National Electrical Code addresses the use of Schedule 80 PVC conduit in hospitals for essential electrical system circuits. It permits the use of Schedule 80 PVC conduit for essential electrical system circuits, but with a significant condition. That condition is that the circuit must not serve patient care areas. The code makes a distinction between essential electrical system circuits and those circuits supplying power to patient care areas. Patient care areas have more stringent requirements due to the sensitivity of medical equipment and the need for uninterrupted power. Therefore, while Schedule 80 PVC might be acceptable for some essential circuits, its use is restricted in areas where patients receive direct medical care. The exception exists to allow for flexibility in design and installation, recognizing that not all essential circuits present the same level of risk. Circuits powering general lighting, administrative areas, or other non-patient care functions within the essential electrical system could potentially utilize Schedule 80 PVC under this exception, provided all other applicable code requirements are met. The NEC defines essential electrical systems as those systems that are necessary for life safety and effective hospital operation during power outages or other emergencies. These systems typically include equipment for lighting, life support, critical care, and communication. Hospitals typically have two or more independent sources of power and an automatic transfer switch to ensure a continuous power supply. There are specific requirements for wiring methods in patient care areas to minimize the risk of electrical shock and fire. These areas require more robust wiring methods and grounding techniques. The NEC provides detailed guidance on the types of wiring methods that are permitted in these areas, taking into account factors such as insulation, grounding, and mechanical protection. It is important to carefully review and adhere to the NEC requirements when designing and installing electrical systems in hospitals, particularly in patient care areas. The term patient care area is a defined term in the NEC. It refers to any space intended for the examination or treatment of patients. This includes, but is not limited to, patient rooms, operating rooms, recovery rooms, intensive care units, and emergency rooms. The NEC has specific requirements for the electrical wiring and equipment in these areas to ensure patient safety. These requirements address issues such as grounding, bonding, isolation, and the use of ground fault circuit interrupters, or GFCIs. The requirements for patient care areas are more stringent than those for other areas of a healthcare facility due to the increased risk of electrical shock and the potential for medical equipment malfunction. Therefore, it is essential to carefully consider the location and intended use of each area when designing and installing electrical systems in hospitals. In summary, while the NEC allows for the use of Schedule 80 PVC conduit for essential electrical system circuits in hospitals, it specifically prohibits its use in patient care areas. This restriction is in place to ensure patient safety and to minimize the risk of electrical hazards. It is important to consult the NEC and other applicable codes and standards when designing and installing electrical systems in hospitals to ensure compliance and to protect patients and staff. Furthermore, local amendments or interpretations of the NEC can exist. Always consult with the local authority having jurisdiction, also known as the AHJ, to ensure full compliance with all applicable regulations. This is especially important in healthcare facilities where safety is paramount. The AHJ can provide clarification on code requirements and ensure that the electrical installation meets the specific needs of the facility. It's important to consider the types of essential systems that might be supported by Schedule 80 PVC outside of patient care areas. These could include circuits for emergency lighting in corridors and stairwells, fire alarm systems, and critical communication systems. The code recognizes that these systems are vital for safety and operation but do not directly impact patient care in the same way as equipment used in treatment areas. Therefore, the exception allows for a more flexible approach to wiring methods in these specific cases. The selection of appropriate wiring methods involves evaluating various factors, including the environment, potential hazards, and the specific requirements of the electrical system. PVC conduit offers several advantages, such as its resistance to corrosion, ease of installation, and relatively low cost. However, it also has limitations, such as its lower mechanical strength compared to metal conduit and its susceptibility to damage from high temperatures. Therefore, it is important to carefully consider these factors when selecting PVC conduit for a particular application. When using PVC conduit, it is important to follow the manufacturer's instructions and the NEC requirements for installation. This includes using the proper fittings, supports, and expansion joints. It is also important to ensure that the conduit is properly grounded and bonded to minimize the risk of electrical shock. The NEC provides detailed guidance on the installation of PVC conduit, including requirements for conduit fill, support spacing, and burial depth. These requirements are designed to ensure the safe and reliable operation of the electrical system. In addition to the NEC, other applicable codes and standards may also apply to the installation of electrical systems in hospitals. These may include local building codes, fire codes, and healthcare facility standards. It is important to consult all applicable codes and standards when designing and installing electrical systems in hospitals to ensure compliance and to protect patients and staff. Proper documentation of the electrical system is also essential. This includes maintaining accurate drawings, specifications, and maintenance records. This documentation is important for troubleshooting problems, performing maintenance, and making future modifications to the electrical system. The NEC requires that electrical systems be properly documented, and it provides guidance on the types of information that should be included in the documentation. Regular inspection and testing of the electrical system are also essential to ensure its continued safe and reliable operation. This includes visual inspections, electrical testing, and thermographic surveys. These inspections and tests can help to identify potential problems before they become serious hazards. The NEC requires that electrical systems be inspected and tested on a regular basis, and it provides guidance on the types of inspections and tests that should be performed. When working on electrical systems in hospitals, it is important to follow safe work practices. This includes de-energizing circuits before working on them, using appropriate personal protective equipment, and following lockout-tagout procedures. It is also important to be aware of the potential hazards associated with working on electrical systems, such as electrical shock, arc flash, and exposure to hazardous materials. Hospitals are complex environments with unique electrical requirements. Understanding the NEC and other applicable codes and standards is essential for ensuring the safety and reliability of the electrical system. By following best practices for design, installation, maintenance, and inspection, it is possible to minimize the risk of electrical hazards and to protect patients and staff. The information provided here is for general guidance only and should not be considered a substitute for professional engineering advice. Always consult with a qualified electrical engineer or contractor when designing or installing electrical systems in hospitals. Finally, it's crucial to remember that electrical codes and standards are constantly evolving. Staying up to date with the latest revisions is essential for ensuring compliance and maintaining a safe electrical environment. Healthcare facilities have a responsibility to provide a safe and reliable electrical system for their patients and staff. By investing in proper design, installation, maintenance, and training, they can minimize the risk of electrical hazards and protect the well-being of those in their care. This also includes ensuring that all electrical work is performed by qualified and licensed professionals who are familiar with the unique requirements of healthcare facilities. In addition to the technical aspects of electrical installations, it is also important to consider the human factors. This includes providing adequate training for staff and the proper use of electrical equipment and the recognition of potential hazards. It also includes creating a culture of safety where everyone feels empowered to report potential problems and to take corrective action. By addressing both the technical and human factors, healthcare facilities can create a safer and more reliable electrical environment for their patients and staff. Another important consideration is the impact of electrical systems on the environment. This includes minimizing energy consumption, reducing waste, and using environmentally friendly materials. Healthcare facilities have a responsibility to operate in a sustainable manner, and this includes making responsible choices about their electrical systems. This can be achieved through the use of energy-efficient equipment, proper maintenance, and recycling of materials. By incorporating sustainability into their electrical practices, healthcare facilities can reduce their environmental footprint and contribute to a healthier planet. Therefore, it's crucial to consult with qualified professionals and stay up to date with the latest codes and standards to ensure a safe and reliable electrical system in healthcare facilities. The NEC provides a framework for electrical safety, but it is only a starting point. Healthcare facilities must also develop and implement their own specific policies and procedures to address the unique risks and challenges of their environment. By taking a proactive and comprehensive approach to electrical safety, healthcare facilities can protect their patients, staff, and visitors from the hazards of electricity. In conclusion, navigating the complexities of electrical codes and standards in healthcare facilities requires a thorough understanding of the NEC, a commitment to safety, and a willingness to invest in proper design, installation, maintenance, and training. By following these principles, healthcare facilities can create a safe and reliable electrical environment that supports the delivery of high-quality patient care. While PVC conduit offers advantages, it is important to be aware of its limitations. It is not as strong as metal conduit and can be damaged by impact or abrasion. It is also susceptible to degradation from ultraviolet light and should not be used in direct sunlight without proper protection. Additionally, PVC conduit has a lower temperature rating than metal conduit and may not be suitable for use in high-temperature environments. Therefore, it is important to carefully consider the environmental conditions when selecting PVC conduit for a particular application. When installing PVC conduit, it is important to use the proper tools and techniques. PVC conduit can be cut with a saw or a special PVC cutter. It is important to make clean, square cuts to ensure proper alignment and sealing of the joints. PVC conduit can be joined using solvent cement or threaded fittings. Solvent cement provides a strong, watertight joint, but it requires careful preparation of the surfaces and proper application of the cement. Threaded fittings provide a mechanical connection that can be easily disassembled, but they may not be as watertight as solvent-cemented joint. When supporting PVC conduit, it is important to use the proper hangers and straps. The hangers and straps should be spaced according to the NEC requirements and should be designed to support the weight of the conduit and its contents. PVC conduit is susceptible to expansion and contraction due to temperature changes. Expansion joints should be installed in long runs of PVC conduit to accommodate these changes and prevent stress on the conduit and fittings. The NEC provides guidance on the spacing and installation of expansion joints in PVC conduit systems. Grounding and bonding are essential for electrical safety. PVC conduit is a non-conductive material and does not provide a path for ground fault current. Therefore, a separate grounding conductor must be installed inside the PVC conduit to provide a low impedance path back to the source in the event of a ground fault. The grounding conductor should be sized according to the NEC requirements and should be properly connected to the equipment grounding system. The NEC provides detailed guidance on grounding and bonding requirements for electrical systems. Electrical inspections are an important part of the electrical safety process. Electrical inspectors review electrical installations to ensure that they comply with the NEC and other applicable codes and standards. Electrical inspections help to identify potential hazards and to ensure that the electrical system is safe and reliable. The NEC requires that electrical installations be inspected and approved by a qualified electrical inspector before they are put into service. Regular maintenance is essential for ensuring the continued safe and reliable operation of electrical systems. This includes visual inspections, cleaning, and testing. Regular maintenance can help to identify potential problems before they become serious hazards. The NEC provides guidance on the types of maintenance that should be performed on electrical systems. In addition to the NEC, other organizations also provide guidance on electrical safety. These organizations include the National Fire Protection Association, or NFPA, the Institute of Electrical and Electronics Engineers, or IEE, and the Occupational Safety and Health Administration, or OSHA. These organizations develop standards, codes, and best practices for electrical safety. Healthcare facilities have a responsibility to provide a safe and reliable electrical system for their patients and staff. By following the NEC, other applicable codes and standards, and best practices for electrical safety, healthcare facilities can minimize the risk of electrical hazards and protect the well-being of those in their care. This requires a commitment to safety from all levels of the organization, from the board of directors to the frontline staff. It also requires a willingness to invest in proper design, installation, maintenance, and training. By making electrical safety a priority, healthcare facilities can create a safer and more reliable environment for everyone. Lastly, be aware that hallways might fall under different interpretations based on their use. If a hallway is directly used for patient transport or examination, it may be considered a patient care facility. Always check with the AHA.